Solving inequalities is very similar to solving equations. You see on your note page that we have the definition of the word solve, which you've seen on 2 or 3 different sets of notes as we were solving equations. And solve means to find all of the values that a variable can be that would make an equation or inequality true. And we had written down before that an equation will have only one answer. For example, it might be x equals -2. So in that equation, x can only be -2. That's the only possible answer. But an inequality that we had written down on our other notes, and we're writing it down here again, an inequality has many answers. It actually has infinite answers, or infinitely many. So the next definition that you see on your notes page is definition for inequality. And as you can see, I have the prefix in, in, underlined. And the prefix in means not. If you haven't learned this prefix yet with Miss Simon, you will. Inequality, it means not equal, just like inappropriate means not appropriate. And there are 4 inequality symbols that you'll need to copy down into your notes. This is the greater than symbol, and there's the less than symbol. And the other 2 are the ones that have the little line underneath, which is greater than or equal to, and this is the less than or equal to symbol. So we have 4 symbols. So in my first example here, x equals -2, there was only one answer. The only answer is -2. But if I have an inequality like this, x is greater than -2, well, I'm going to put a circle around -2, and since it says x is greater than -2, any number that's greater than -2 all the way to positive infinity, any of those numbers would work. And that doesn't just include whole numbers like you see on this number line, it also includes everything in between, like 1.5 would work, or 3.9 repeating would work, or -1.6. So there are an infinite number of answers, not just one, like in this first example, where there was only one answer. The only answer was -2. This is anything bigger than -2 will work. So we've seen these notes in a bunch of other videos. We're going to just remind ourselves really quickly that we're going to solve these problems using inverse operations. And the inverse are operations that undo each other. Addition undoes subtraction, and multiplication undoes division. We're going to remind ourselves to use a balance line that reminds me what I do on one side, I must do to the other. And this is the only new part, this part down here in blue that you'll record on your notes sheet. It's on the left-hand side of your notes sheet. It says, get the variable on the left side so that we can graph. So we're going to have this one extra step of just moving the variable to the left side so that we are able to graph it. On your notes page, you'll see open or closed dot, and the closed dot will happen when we have these 2 symbols, when we have the greater than or equal to symbol and the less than or equal to symbol. Because we have that extra line that means that equal to, this example is x is greater than or equal to 35. That little line means that x could be equal to 35. So that's why this dot is shaded in. And everything greater than 35 could also be an answer. 36, 39.7, 125, all of those would be solutions. So the circle is filled in because this line says that it could be equal to 35. And an open dot is just the opposite. An open dot is the symbol greater than or the less than symbol. And in this example, we see x is greater than 35. This is the example, x is greater than 35. Since that little line doesn't appear, I know that 35 right there is not a possible answer. It has to be greater than 35. So I'm leaving 35 out, but everything greater than 35 could work. Even 35.001 would work, and everything larger. So that open dot means that the value is not included. The closed dot means that the value is included. And so you can remember it by if there's that little line underneath, that line that means equals to, there's an extra line, which means you have to do some extra coloring. The extra line means you have to do some extra coloring. So here we have some examples of that same idea. And this is not on your notes page, so I'd just like you to watch. This first example up here at the top, I see that it's a closed dot. It's filled in. So I'm looking for a symbol that has the line underneath it. That means it's equal to 35. 35 is okay. And since this arrow goes to the left, I can tell that those are the less than numbers. So that must be x is less than or equal to 35. This second example has an open dot. That means 35 is not included. So I'm looking for a symbol that doesn't have the equals line. And I see that it's shaded this way, which are the greater numbers. Those are all numbers that are greater than 35. So I'm looking for x is greater than 35. This third one was already done for us as an example. Let's check. It was shaded in, which means that there is an equals line, and it is the greater than numbers. So I agree with this. X is greater than or equal to 35. And let's check this last one. This open dot means that there is no equals line. And these are the smaller numbers. These are all the numbers that are less than 35. So that must match this. X is less than 35. So here are the 4 different symbols. And you can see that even though the graphs are similar, they all are different. They're either open or closed, and the arrow is going one way or the other. So they are different. They're similar, but they're different. These 4 graphs appear on your notes sheet, and I'd like you to sketch these examples. The first one is x is less than 45. Since there is no equal sign, I know it's going to be an open dot at 45. And since it says less than, the arrow is going to be going to the left. The second example, x is greater than or equal to 25. Well, since there's that equal sign, there's that closed dot, that means 25 is good. And it says greater than, so everything is going to the right. I'd like you to finish those next 2 graphs on your notes page before we move on to some solving. So here we have 2 inequalities. They appear on your notes page. I'm going to do the same steps that I did before. I'm going to put in a balance line. What is my variable? X. What do I need to move away from the x? I've got a plus 8. The opposite of plus 8 is minus 8. This is a 0 pair. So now I've got x plus 0, but you guys know I'm lazy, so I just write the x. And the symbol is greater than. 9 minus 8 is 1. X is greater than 1. On my graphs that I have down here, I'm going to show my open dot at 1 and my arrow pointing to the right. On your paper, here's all I really need from you. I need you to show a short number line, and the only numbers that need to be on it are 1, and one number smaller, like 0, one number larger, like 2. And you're going to show an open dot at 1 and the arrow going to the right. I don't want you to spend time making number lines with all these numbers like my examples. I just need you to do what I just showed as a sketch. That's why your paper, your notes page says sketch a graph. And one easy way to help you remember which way the arrow goes, if my variable is on the left, where it should be, like this one, this symbol actually shows you which way the arrow goes. It goes that way. And as you can see, that matches this graph. So on this next example, I'll do the same thing. I'm going to put in my balance line. I'm going to circle my variable, which is m, and I get rid of plus 7 by doing minus 7 on both sides. This is a 0 pair, and m plus 0 is just m. This symbol is the same, and 10 take away 7 is 3. Now, if I went back to that very first page, we said that we had to put our variable on the left. So I've got one more step right here. I need to rewrite this expression. I'm going to put the m on the left and the 3 on the right. And now I want you to watch carefully, please. This symbol was facing toward the m, or if we were using the way you learned this last year, that the alligator mouth is eating the m, or the Pac-Man symbol is eating the m, it still needs to be facing that same direction. So since the opening was towards the m, it still needs to be toward the m. So I basically just flipped everything around. I rewrote it so that the variable was on the left. Here's what your sketch should look like. I'm going to put the 3 in the middle and one number smaller, one number larger. And now I need to figure out, is this an open or closed dot? Well, since it has that extra line, that means m could equal 3, so I want to fill that in. And it says m is greater than, so my arrow will be going that way. And that's, again, what my symbol is showing. It's pointing to the greater than side. Here are 2 more examples for you to solve. X plus 15 is greater than 29, and x is less than 23, or excuse me, x minus 23 is less than or equal to -9. I would like you to do those problems and sketch a graph. So just like I've shown in this video, what your graphs should look like. You only need 3 numbers. You don't need a huge number line. And 2 final examples. And again, just a sketch of the graph.